Good afternoon, student, and welcome to today's lesson where we'll look at OSI reference model. What is OSI reference model and what does it stand for? Why was it designed or developed? Before we look at all those questions, let's just discuss something which we did before or earlier in classes. Let's look at what is computer network or what is a network. So we say the computer network is when two or more devices or computing devices are connected together to share information. So for you to have or to set up a network, you need computing devices that are linked together. And it's for the purpose of communication and also sharing information, resources. Sorry me, please. So now how do these devices share information? How do they communicate? So now in the olden days, when forming up a network, it was only the same devices that can able to communicate in that certain network in the olden days. So only a certain manufacturers devices that can communicate. So, but if they are from a different or a certain manufacturers, then that device, that computer, whatever you are connecting to the network, it cannot communicate or cannot communicate with the other devices within the network. So now to break that barrier, the International Organization for Standardization, which is ISO, developed this model to cater or to break the barrier of compatibility, because some devices could not access the network or cannot be part of the network to enjoy the resources of that certain network. So now for all these computing devices able to communicate, there was a model that was developed so that all the manufacturers can able to follow certain standard such that if a user buy a device will not experience any problem connecting to a certain network. Okay, so now what is OSI reference model? The OSI reference model describe how information from a software application in one computer moves through a physical medium to the software application in another computer. As we can see here, the OSI reference model, we said it's just it's a standardized framework on how information is shared between computers, because when the computers are on the network, they do share information, they do communicate. So how do this information communicate? So now this layer is condensed into 7 layers, or it's made up of 7 layers, which you have application layer, presentation layer, end session layer, transport layer, network layer, data link layer, and physical layer. So all this layer is what makes up the OSI reference model. So whatever, when the manufacturers designing or manufacturing their devices, they take into consideration of this standard. Okay, so they follow this standard. So now this layer or this OSI or the model is divided into two layers. We have got the upper layer and the lower layer. As you can see here, we say the upper layer is responsible for the host, and the network, the lower layer is responsible for the network. Right, now if you look at all these layers, each and every layer have got its own purpose or its function, which you are going to discuss or to look at below here in our presentation. But let's just quickly go through these bullet points here. So we said the OSI consists of 7 layers, and each layer performs a particular network function. That's what I've said. So that each of these layers have got their functions, and they are all 7. And it was developed by ISO, which is International Organization for Standardization, in 1984. And it is now considered an architectural model for the computer communication. One of the examples that I can give you or a scenario is that for us to understand what the OSI reference model is. You know, when you're building up a house, the first thing that you start off with is the plan. You draw up the plan on the paper or whatever you are using. So it's you draw up the plan, and you go and give it to the people, the contractors who are now building the actual house. So now the drawing up of this, the prototype, I mean the drawing up, this plan, it's what actually referred to, or is similar, can be related to the OSI reference model. So when the builders now are constructing now the actual house, they go according to the plan that was designed. So this is the same as the OSI reference model. So all the manufacturers that are manufacturing certain devices, they need to follow some certain standards for so that this device doesn't give problems in computing environment. So now the OSI model divides the whole task into 7 layers, into 7 small and manageable tasks. So this is what you say that the layers, this model is divided into 7 layers. So if there is a strategy that you use to remember all these layers in the order in which they are, because this is how you should write them in this order. So we're starting off with the application all the way to a physical layer. So what you do is you take the first letter and you make a word out of it. Like for instance, the one way of remembering this layer is there's a technique or a strategy that you usually say A for all, P for people. So you say all people seems to need data processing. So all people seems to need data processing. And then you just write it with, you replace the all with the actual name of the layer. That's how you can use, that's what you can use to remember the name of these layers in the order in which they appear. Okay, this is what you said, that it's divided into 2 layers, the upper layer and the lower layers. And you say the upper layer, it consists of, or it manages, it's responsible for the host, and the lower layer, which is responsible for the network. So we say the upper layer of the OSI model mainly deals with the application related issues. So we are saying that this layer, the application layer, are related or handles, or they deals with the application related issues, and they're implemented only in the softwares. So things like if you want to send an email, you need an application that does that. Okay, so all those application related issues are handled in these layers or by these layers. Okay, so both the end users and the application layer interact with the software application. So as a user, like if you want to send a WhatsApp message, what do? You go to your phone, you launch the application, which is WhatsApp, and yes, and you just send your messages. If you want to send an email, you do the same. So that whole process, all those application related issues are handled by these upper layers of the OSI. And then the lower layer of the OSI model deals with the transport layer, with data transport issues. So you write your message and you want to address it to a certain person. So who is going to transport this message? Okay, so that what actually the data, the lower layer deals with. Okay, it deals with data transportation of your message or data. Now looking at the function of each of these layers, the 7 layers, the OSI reference model layers. So as you see that we've got the application layer at the top, we say this layer provides the services to the user. Provide the services to the user. The user could be me, even me now when I'm on this laptop doing this presentation. So all these applications that I'm using here, they are being handled by the application layer. So without this layer, I cannot able to even to browse for information on the internet. I cannot even send an email. I cannot download anything. I cannot upload a file or whatsoever. So we need this application, the layer to handle these applications that you're using as users. And then the next one is the presentation layer, which is responsible for translation, compressions, and encryption. So as we know that the computer understands zeros and ones, so when the message is being sent, this information is translated or it's changed to languages that the computer understands, or the language that the computer understands, and also the compression of data, because the data sometimes need to be compressed so that it decreases in size for easier transportation, and so forth and so on. And then encryption as well, data encryption, because we need to encrypt our data. If we don't do that, then somewhere there are hackers sitting in the middle between the sender and the destination or the receiver. Then if you don't encrypt your messages, it will be hacked. And security also happens there, or the presentation layer also handles the security issues. And then moving on to the next one, which is session layer. It is used to establish, manage, and terminate the sessions. Okay. So as it says, it needs to establish, or is used to establish, manage, and terminate the sessions layers. Okay. So with that, a good example will be if you're making a phone call. So what you do is you dial the number of the person that you're calling, and then you wait for a few minutes or few seconds for this person to respond or to pick up your phone. So what this session does, or this layer does, is it establishes. So first you dial, and then this um, a session need to be established. So there must be establishment. It needs to be set up. So the session between you and the person that you're calling. So that session need to be established. And then when you get connected to the persons that you're talking to, that services or that session need to be managed. So there shouldn't be anyone that tries to call and allowed to talk to the other person that you're talking to. So if there is no one managing that, then this create a problem as well. So that session need to be managed in that way. And then the next thing is it also terminate the session. So once you're done calling or done talking to the person that you're talking to, then that session need to be terminated. You cannot talk from January to December. So it needs to be terminated. Okay. So the layer that handles that is session layers. So it deals with sessions. And then moving on to transports layer, which provides reliable message delivery from process to process. So for the transportation of messages from one place to another. So who does that? Is the transport layer. So moving data from one place to another is the transport layer that handles that. So and then moving on to the network layer, we say it is responsible for moving the packets from source to the destination. So as we know that we've got different networks around the globe, and we normally use to send our data to these different networks. So our packets that you are sending are routed to different networks. But sometimes you'll be required to send a data packet from a different network. So now the person or any different network that you really don't even don't know. So now the person that the layer that is responsible for identifying or checking which network are you sending that data packets to. So the system need to know that you are sending a data packet to a different network. So your packet has to be routed, and for that we need the network layer to forward our packets from its source to the destination. So the network layer help us in that regard. And then the data cleaning layer is used for error-free transfer of data frames. Okay, to check and correct all the errors in our data frames. If there are any errors in our data, then they are checked and corrected here. And then a free error the data without errors, then it's being transmitted from the source to the destination. Okay, so if there is any error that is encountered, then it has to be corrected, and then it sends to the destination. And then the last layer here is the physical layer, which provides the physical medium through which bits are transmitted. Okay, because we said our network are made up, or computers or devices are connected using keyboards. Okay, so now once all these layers, the packets, the data your data goes through all these layers. Now it has to be put onto the physical medium, which takes it to the destination. Okay, and then looking at this diagram here, as we see here, as you can see, these different layers here, the layers of the OSI reference model. So you see, the packet or the PDU, to call PDU, travel from one layer to one another, from one layer to another, from one layer to another. So now, as the packet PDU, it's being forwarded from one layer to another. All these layers, each of them add its own additional information to that data packet. And when the data packet reaches, or this data reaches any layer here, then there's a name that is assigned by that, or that you have to be referred to. That is actually referred to when the data is in that certain layer. Like for instance, if we start off with the application layer. So with the application layer, the bits on the application layer, I mean physical layer, which is the last layer here, we call them bits. So they're bits. And then frames on the data link. So the data link layer, we call them frames. And on network layer, it's packets. And then on the transport layer, we refer to them as segments, right? And then the first three layers, um, the application and presentation and session layer, there is just data. Okay, so if you look at this diagram here, so this is the PDU. This is the actual data that is being forwarded from one layer to to the other. So as you can see, it's not changing in colors, it's just represented there in black. But now if you look here, when this data PD is forwarded to presentation layer, the presentation layer also add some additional information, as you can see here, right? And then the session layer also add its additional information, and so forth and so on, until it reaches the physical layer. So this is now the source, this is where the data is coming from, and this is where it's going. This is the destination. So the destination also has got the 7 layers as well. So once the data packet is received at the destination, all these layers removes what was put by its corresponding layer. Like physical layer, it removes this section here, and so forth and so on, until it becomes now the actual information that was sent. Okay, so this is how the layers of the OSI reference model actually works in data communication. So that's it for today. See you again in the next lesson. Bye.